Hello there, welcome to our project assignment 3 data plane by Maria, Ben, and Julian. Today we're going to be going over this assignment, starting with the first part, where we're going to send a message that is at least 80 characters long, and we're supposed to split that into two separate packets. So I'm going to first run simulation.1 just to show you how that it works. Let's do that real quick. Alright, so it does work. Everything starts and ends correctly. And I'm going to be using grep because all this text looks like nonsense. I'm going to grep receive so that this process is a little more easier to read. Receive. Here, looks like we received two separate packets, which is exactly what we need. And let's go back into the code. Our sample data is this. If we really want to see what the length is, let's grep length. And it should turn up as 80. There it is. So it's 80 characters long. We're only sending this once, and it's going to be broken into two separate packets. So let's move on to the second part. For the second part, we are supposed to do essentially what we did in the first part, except we have to segment all the packets that we're going to be sending if the message length is longer than the MTU. In this case, we have MTU of 30, which is pretty low. So we're going to need to segment our message. Here it is. Let's check the length. It says here that is 215, so 215 characters. So that's going to be split into many packets. And we see here that we send this data 3 times. So let's run this once again. Simulation, Python, simulation. This is 2. That is a lot of going on here. So we're going to use grep again, little friend, to facilitate this process. So let's grep packets, PKTS. This will show us all the packets that are being sent, and you can see here there are a lot because we are sending the same sample message 3 times. We can observe here that there is a header so that it is reassembled and segmented well. Here is the message or the little contents of the packets. Now, is it being reassembled correctly? Let's check that out. We're going to use our little friend grep again. Here are the reassembled messages. We can see that there is a lot of the same thing going on here. That is because if we go back to simulation, we're sending this 3 times. So if we want to be extra precise, we could do WC, count how many times reassembled has been called, and we'll see. And here it is 3 times, which is correct because we're sending it 3 times.
The third part of the assignment had 3 objectives. Change the network topography, make a routing table, and make sure that host 1 goes through router B and host 2 goes through router C. So first we'll look at the network topography. As you can see, we added in a host 3 and 4, as well as router B, C, and D. This number right here relates to how many things are connected to the router. So router A has connections to host 1, 2, as well as router B and C. Down here, we have actually linked them together. Host 1 is connected to router A, etc. These numbers show which interface number it's related to. So router A's number 1 interface is related to host 2. Router B's number 2 interface is connected to host 3. This relates to our routing table, which is the next important part up here. Simply, I just put tuples together. We have the first number is the interface and the second is the host. So for A, when it goes to interface 2, we know that we're routing to host 3. In this way, you can tell that host 1 will always go through router B and host 2 will always go through router C. Let us run the program and show this same thing. We only sent one message from from host 2 with the destination of host 4. You can see that host 2 linked to router A, and we were given a forwarding table. Then from this forwarding table, it routed A to C, and then C to D, and D finally made it to host 4, which received the packet. We can run this again with host 1 going through router B right here by changing the code and running it again. As you can see, the same thing happened. The forwarding table changed based on where it was coming from and going to. We went through router B instead and still made it to host 3, which received the packet. Thank you. Good night.